This is the kind of session that usually attracts a huge room because it talks about the subject none of us really want to talk about, which is the economic reality that confronts us in technology. The economics are rarely in our favor, and despite what the vendor said who sold you your last piece of gear, chances are you're challenged by the economic realities of your environment if you're like most companies. For informational purposes only, this is the terms of the presentation. Everything I say is my responsibility. CA bears no responsibility for it whatsoever. All right, the basic things we're going to cover today in this talk for about the next 30 minutes are, number one, in a very general way, the notion of storage economics. We're going to see what the impact is of the current trends that are driving data to amass itself in our storage infrastructure. We're going to look at the options for how we stage that data, how we host that data, how we protect and preserve that data. And we're going to look at what the current topics are for managing data across infrastructure in a frictionless way. And I'll explain what that means as we go forward. And then I'll summarize by giving you my 2 cents for what it's worth of how you can go about putting your arms around the economics of your infrastructure. Now, storage economics is actually becoming kind of a trendy topic, mainly because of the impact of several things. We've seen the growth of the digital democracy. We have seen mobile commerce, and we've seen also the Internet of Things, all of which are huge drivers of new data in our infrastructure. And according to the analyst, depending on the analyst you read, we're looking at between 10 and 60 zettabytes of data that will require storage capacity by the year 2020. Now, what's a zettabyte? It's 1,000 exabytes. That's a lot of data. That's a lot of capacity requirement to store that data. And that's putting attention in a lot of people's minds on what it's going to cost to store that quantity of data, especially the cloud service providers, but also large data centers as well. Now, the Internet of Things is, you probably would have had to have your head buried in the sand not to have read a million articles or seen a million presentations on IoT in the last couple of months. It's been a hot topic, trending for quite a while. Basically, we have seen about a 50% reduction in the cost of sensors that collect information. We've seen a massive reduction in the cost of bandwidth to transmit the information from those sensors, and we've seen a 60% increase, or a 60% reduction in the third little component over here, the cost to process that data through online, all the time analytics databases. So that combined with greed is kind of driving the Internet of Things forward, even if consumers have been slow to adopt it. There's currently a war going on among the telephone guys and the smartphone guys to see who's going to own the data for automobiles, for example. There are 250 sensors in a General Motors car, including a sensor that weighs you when you sit down in the driver's seat. And Apple is currently bidding large amounts of money with GM in order to get access to that data so they can do interesting things with it. So even if you're not into Internet of Things today in your shop, chances are the whole ball is going to move forward simply as a function of the interest of the smartphone manufacturers. We've also seen a tremendous high and to the right spike in mobile commerce. In the United States, we saw last year about $82 billion of transactions done through mobile commerce. This year, we're expecting, according to one analyst, $628 billion, probably centered around Christmas and Black Friday and the following Monday. There were 22.14 exabytes of data, just orders created just from smartphones in the past year. And folks are identifying the fact that the bigger the screen, the more money people spend. So, if you want to sell a lot of money, give everybody a free tablet and they'll go out and spend using it. And as long as the tablet screen is enormous, you'll sell more to them than you would if they just had a little small smartphone. Okay, and basically that drives the whole notion of the hybrid data center, this mobile commerce thing. If you've watched IBM's presentations on this, and probably the presentations of a number of others, they divide the world of your data center into several component parts. You have down at the systems of engagement, these are the mobile phone apps and the apps that run on your smart devices, on your tablets, and on your desktop even. And basically customers use those apps to select a product. They send that product over a wire to the systems of interaction. These are usually x86 platforms running a hypervisor-based software package for catalog lookup, for order taking, and so forth. And they basically handle the customer service and bringing the order from the customer in. And then they shunt the data over to systems of insight. These are often Hadoop clusters with MapReduce, and they spread a myriad of transactional processes across a broad number of clustered servers in order to, number one, validate that you are who you say you are. Number two, make sure that the credit card or other instrument you're using to pay with has sufficient money in it to be able to afford what you're buying. And number three, to evaluate you as a customer and to try to upsell you. So that if the last time you were on the site, you looked at this other product, they can come back to you and say, oh, by the way, the last time you were here, you looked at new tires for your car. You know, there are some really good tires that are 30% off list now if you want to add those to your order. So the whole concept is they want to upsell. Now, assuming that you pass muster, you've got the money to make the purchase and whatever, your data goes into the back-end systems, which some of the app dev guys derogatorily refer to as legacy systems. We call them systems of record, and they are the real money makers for the company. Everything that comes into the company in terms of revenues happens at the systems of record. These are enterprise resource planning, inventory management, logistics management to make sure the customer gets the product shipped to them that he ordered, and a number of other kinds of functionality, customer relationship management and so forth. These are the bread and butter operations inside your data center. And they're really where the money comes from. It doesn't come from the other aspects of computing directly. It only comes from the aspects of computing that you see at the end of the day here. Now, in addition, the hybrid component of this is that they are using infrastructure as a service offerings from cloud service providers and perhaps something like DR as a service or DRaaS as augments and as ways to elastify what they are using in their home data center. So you've got a private cloud, which is your on-premise data center, and a public cloud, which are these additional services, and where they intersect, we have what's called hybrid cloud. More and more companies are adopting this model. It's sort of a way for the larger company to get his toe wet in the cloud business because large firms have been reluctant to embrace cloud with the same alacrity as the small and medium-sized firm has. And the story should be over at that point. We're all happy, customers are getting what they want, you're getting rich, it's a happy day for everybody. And that's growing an awful lot of data. Then the third component for data growth is, as I said, the digital democracy. This is kind of where my interest began, and it was back in, I think, 1999, University of California at Berkeley did a study, and they determined that in the total existence of mankind, the total amount of data that had been stored electronically was about 11 exabytes, and that they expected that to double in 2 years. And that seemed like a lot of data back in those days, right? Today we're talking about zettabytes of data, and it's basically everything you once understood to be analog, whether it was a book that you'd read in your hands or music you bought on a piece of vinyl or a VHS cassette tape, it's all now digitized. And that digital data is beginning to flood all the networks and take its place on your storage. So storage is growing gigantically. And when you think about it, 10 to 60 zettabytes plus this cloud infrastructure is going to require an awful lot of storage to handle the data that's amassing, right? And that storage equals cost. Simply put, storage today commands somewhere between 33 and 70 cents of every dollar spent on IT hardware. So it's not an inconsequential or a trivial cost. Going forward, the capacity demand is going to outstrip the supply. It's creating something I call the Zettabyte Apocalypse, just for kicks, okay? Basically, what it really comes down to is this. The cloud guys were the first ones who turned me on to this. Microsoft Azure did a presentation on it, and it was very fascinating. They said, look, we're looking at between 10 and 60 zettabytes of new data coming into our infrastructure by 2020. The total capacity of the disk drive industry is about 780 exabytes of capacity. The total annual output of the flash industry is about 500 exabytes. Okay, these are orders of magnitude less than zettabytes. So when you do the math on it, you realize that if we realize the full 60 zettabyte total of new data, the total output of all of the industry in terms of mass storage devices in the disk and the flash categories is going to represent less than 2% of the demand. Even if you were able to buy all of the manufacturing output between now and 2020, you'd only be able to host 2% of the new data that's coming. If it's the low end of the spectrum, it's about 10 zettabytes, you're looking at a slightly better outcome, about 13%. But it's still not enough. Okay, where is the extra capacity going to come from? I asked Microsoft Azure, why do you want to create an infrastructure for every man? Why don't you just sell your limited amount of capacity at a higher cost to those with deep pockets who can afford it? And they said, do you have any idea how much money you're leaving on the table if you don't create a mass storage platform for everybody to upload, the picture they took of their Happy Meal with their 200 megapixel camera on their cell phone? And so the idea is we have to figure out a way to store all the bits. The capacity demand is growing, and the leading analysts actually were on to this back in 2011. IDC did a report. They said that the total amount of data requiring storage amounted to, if you used the amount of storage that was deployed worldwide, it was about 11 exabytes of storage that were deployed worldwide, 22.1 exabytes, and it was going to grow at a rate of about 40% per year. So that was where we were standing. The industry was okay with that because we could increase output by 40% per year, no problem. And then last summer, they said, wait a minute, with these new technologies for doing data storage, particularly isolating and stovepiping your data behind a hypervisor in an x86 platform and replicating that 3 times, there are 3 nodes in a vSAN from VMware, or 3 nodes in a cluster, a shared cluster from Microsoft, that you were actually looking at 300% per year capacity growth, not 40%. They had badly underestimated the growth rate. And then Gartner, not to be outdone by their little redheaded stepchild there, said, no, it's more like 650% because you're failing to address the need for high availability, which means for every clustered system you set up over here, you have to have an identical one for it to fail over to if it ever has a bad day. So 650% growth in storage capacity demand per year is a lot of money. And it's sort of frog in a pot. A lot of companies haven't paid a lot of attention to it. But last year they did an analysis and they discovered that, hey, this whole hypervisor computing thing has gone pretty crazy. People have adopted it in a big way, creating their own local clouds. And today, if you look at the map here, 29% of your infrastructure is used to handle 75% of your workload, which are virtual machines crowded onto storage behind hypervisor-based systems. Okay, the other 71% is handling 25% of your application, but those are mission critical online transaction processing systems that nobody virtualizes because they're afraid they're going to slow them down. So now you've got this kind of interesting phenomenon occurring of bifurcation in the data center. And when you look closely at the 75% number, what we just discovered last year in a bunch of surveys that were taken by TechTarget was that companies were saying, look, we don't want to just be a one-trick pony here. We don't want to just go with one hypervisor vendor. We're going to diversify our hypervisor vendors. So each hypervisor has its own rigid, defined silo of software-defined storage behind it and will not work and play well with its competing hypervisor. So now we got balkanization in the lion's share and we're not using our storage very efficiently. Software-defined storage, for those of you who are primarily mainframers and don't follow the data center, distributed data center very much, is an old concept. In fact, it comes from us. It comes from the mainframe folks. They say it's new, but it really isn't. In 1993, we had system managed storage on IBM mainframes. We had a bunch of brain dead storage devices called DASD, they were JBODs, and we would give them a personality by taking a stack of software services that were in SMS and assigning them over to the logical volumes that we cut out of those JBODs. And that's essentially what we're doing with this newfangled software-defined storage that the hypervisor guys are all hot about. We take all the value-add software that used to live on the array controller and we move it over to the server as a software stack. And then we reduce that storage device down to its generic components, which theoretically will reduce its price quite a bit, okay? And that's the theory of how it's all supposed to work. And now, to make it even more simple for small companies to adopt software-defined storage, the server vendors are combining a stack of software with a hypervisor immediately on ahead, and they sell it as an appliance. So now we have what's known as hyper-converged infrastructure, which is an appliantization of software-defined storage. Each one of these software-defined storage kits have a minimum of 3 nodes of storage that replicate between each other in order to provide high availability in the storage kit that's associated with the server. And then hyper-converged infrastructure appliances are set adjacent to each other where they can serve as locations for high availability failover for each other. Okay, that's basically been the model. Now, you would think that this is a wonderful thing based on the latest Gartner study. I'll give you the reference so you can go look it up yourself. Gartner said that after we started doing this, after we started siloing storage behind a hypervisor, that we saw the cost of storage decrease from a management standpoint, from an acquisition and management standpoint. A virtualization administrator working on his server could manage his storage much more efficiently. He had nothing in his way. He didn't have to go carve it out of a SAN or use shared storage. It was directly attached to his own box, and he had full control over it. So it looked like, hey, that's good news, you know, the lower cost per terabyte, right? And then they said the other thing that happened was the amount of storage that a single server administrator could manage had increased substantially. It had gone up over 100 raw terabytes to 344 terabytes per server that you could manage without any additional help. And that sounded like a very good thing too. 2 enthusiastic thumbs up. Except that when you read the back matter, you discovered that something else was happening here. By siloing storage behind each one of these servers, we had a net reduction in the efficiency with which we were using the available space. You might have 30% of available capacity behind your server, but your fellow administrator who's doing a Hyper-V rather than a VMware can't use any of that storage when he's running out. Because number one, he can't see it, and number two, it's in a different format and it only works with VMware. Does that make sense? Okay, so we're basically shooting ourselves in the foot there. Plus, you know, this whole notion of siloing storage behind hypervisors has led to some fairly crazy ideas that run afoul of what we've always commonly used as a way to cap the cost of our storage infrastructure. You know, we used to use tiered storage. What is tiered storage? You stick your data at the most expensive tier while it's hot, and then as the data cools and access and update diminishes, you migrate that data down to less and less and less expensive and more capacious and sometimes less performant storage media until finally it would end up on tape, which is where 80% of today's data lives, is on tape. Okay? Now, there are those who say, well, that's not going to work for us. We're going all silicon. We're going all flash. We're going to get rid of all these tiers, and we're going siloed. So that means we're going to do some other kind of storage mechanism here. This is basically the tiering that I just discussed. At a petabyte of storage, if we used all the tiers, we were talking about $587,000 for the cost of a petabyte of storage. Okay, because we were tiering the storage and moving the data around to less and less expensive tiers. But if we were only using the tier 0 stuff, we were talking about 1.5 million. So half the price if we move the data down based on its access frequency and update frequency. Does that make sense? However, there are other people, you know, I call them storage girly men. I don't know, other people probably have other names for them. But they think, no, what we need to do is go flat and frictionless. We are using, the only data migration we support is template cut and paste, vMotion. The ability to move workload from one machine to another for load balancing purposes. However, when the data itself becomes less frequently used, and is reduced in terms of its frequency of access and its frequency of update, what we do is we shelter in place. Those of you who are as old as me understand what shelter in place was. It was a strategy where if there was a nuclear explosion out here in Nevada, we were supposed to all dive under our school desks. You remember? All right, it wouldn't have worked, and this doesn't work either, by the way. The idea here is that you've got DRAM and you've got flash, and you create your storage nodes with that. And then as the data goes to sleep, you simply quiesce the node, you turn it off. and you leave the data where it is. You don't migrate it, you don't back it up, you don't archive it, you don't do anything. And in the manner of a grad student in a research lab, you just roll out more nodes. Okay, and that's actually a strategy that some companies are adopting to basically protect and preserve their data. Doesn't work very well if you get hit by a hurricane or an earthquake or a building fire or something like that, or if you try to re-energize the storage devices that you were running for a few months and then they die on you when you try to turn them back on. There's no longitudinal data right now on the durability of flash. Okay, we have lots of data on the durability of disk. And we know very well that if you use disk for a protracted period of time and then you power them down, you've got a fairly sizable failure rate when you go to restore the disk back to productive use. And here is the back of envelope math on what a zettabyte of data costs in each one of the storage media. If you wanted to store a zettabyte of data for a year on NVMe flash, today it would cost you $1.15 trillion. 1 zettabyte on flash. Okay, in 2020, with the declining cost of flash, it'll be about 238 billion. So if you got that money, go for it. You know, you're in. All right. If you want to do it on tape, today it would be 8 billion to store a zettabyte. By 2020, it's going to be 1.9 billion. Significant difference. Okay, and for a very large company or a very large cloud service provider, much more to their liking, I think, in terms of what their cost is. There are other attributes of each one of these storage media that you need to take into account. In the case of NVMe, it's not really optimized for fast writing. It's really an optimal medium for storing data that you're going to read a lot. So it makes it really good for reference data, but it isn't really the ideal platform for write targeting, regardless of what your all-flash array vendor tells you. Secondly, a disk is running out of speed with perpendicular magnetic recording. Right now we've reached kind of the limit, and we got HGST adding platters and in a helium-filled container in order to boost the capacity of a hard drive. That's not going to serve us for very long at all. Instead, what we've got are some efforts by Seagate and others to introduce heat-assisted magnetic recording or acoustically assisted magnetic recording or some other strategies to boost the capacity of storage. But we're not sure if those are going to come to fruition or yield us better capacity by 2020 when the Zettabyte Apocalypse occurs. So that's a real question mark. And then on optical disk, we've been promised a 1 terabyte Blu-ray. Okay, and it may get here by 2020. 1 terabyte isn't enough capacity. Okay, and on a per unit basis, I mean, you look at the numbers, it's going to be $4 billion to store a zettabyte of data for a year on Blu-ray. All right, now disk-based storage is still predominant in mainframe data centers. Mainframe data centers tend to be in 70% of the Fortune 500 companies. Okay, I checked these numbers, you can read them yourself, what it costs for DASD these days, what the average cost is. This was in a blog by a qualified guy, and I bounced it off IBM's experts, and they said, yeah, that's about right. So what we're talking about here is a 3390-3 volume, which is about 3 gigabytes of storage, costs you about $84.90 to acquire, but not including maintenance and environmental, so HVAC, right? And then when it gets full, or it's full of data that is stale data, is no longer useful data, it costs, actually at the end is the bottom line here, it costs less to reclaim that storage by archiving it than it does to buy more storage. So there is still a value in archive. There is still a value in tiering. And we can't ignore that, as trendy as we want to be. It isn't going to make chicks dig you or guys want to be you because you decided to abandon hierarchical storage management. Okay, and the push is on, obviously, for mainframe flash systems. Probably half of the hardware vendors who are present at today's show and in other shows I've been to are pushing all flash. And they have a claim to make that, you know, at great largesse, you know, when you have a lot of disk-based storage and you're short stroking the disk, you're only using part of the disk in order to get maximum performance out of it, that a flash array is going to be cheaper than the disk drive. And that's true. It's very true. So either we figure out a way to mix and integrate the different forms and go to an all-of-above strategy and maintain some sort of a hierarchical storage management, or we're going to end up swamped by the zettabyte wave. Okay, so I'm not as sold on flash as some people are. Right now, these are the numbers that Fred Moore knows more about this stuff than anybody I know in the industry is articulating. He says that on your tier 0 stuff, you're going to put about 1 to 3% of your data. On your tier 1, which is your fast disk drives, you're going to put probably 12 to 20% of your data. This is mission critical, frequently re-referenced and updated. And then for the stuff that's gotten a little colder, you're going to go to a higher capacity, probably a SAS SATA array, and you're going to be basically keeping about 20 to 25% of your data there. The rest of it's going to go to tape. And you're saying tape, you know, I hate tape. Well, still has a very solid technical business value case if you look at tape. And that's what really counts at the end of the day. We have barium ferrite coatings on tape now that allow us, they've already demonstrated 220 terabytes of uncompressed data on a single LTO cartridge. Barium ferrite is the shiny new thing in tape, basically. And then for ease of use, you've got something called the linear tape file system, invented by IBM, contributed to ISO, and developed as an ISO standard now. So now you've got an ability to take data and copy it to a tape without any interstitial software, without a conversion of a file system, without a backup software package, without an archive software package. You simply copy it like you do to a USB key. And then you can retrieve it simply by inserting the tape into the drive, and it spells out from the top partition on the tape, it is able to read the contents of that tape, and it gives you a directory layout of the tape, or an object layout if you're using an object system. So LTFS makes it a lot simpler to use. Data access time is really determined by the library, but expect the worldwide wait if you're going to a big library, maybe 2 minutes and 20 seconds to get to a remote piece of data on an outlying tape that needs to be gotten by a robot and stuck into the thing. The actual spin rate of tape means that once the tape is inserted into the drive, it's less than 45 seconds to get to the endpoint on either side of the center point. That's pretty okay. And then jitter-free streaming once it's going with the fastest read rate and the fastest write rate of any media on the planet. Now, what does this mean? If you're a pharmaceutical company and the FDA just decided that now all clinical test trial data on your particular medicines need to be stored in a near online state, and maybe you can't get electricity pumped into your data center, you can go to tape. And tape means that, you know, if the FDA needs to look at your clinical test trial data, it may take 2 minutes for them to access the files they're looking to retrieve, but who cares? It's the worldwide wait. And you are in full compliance with the governance, risk, and compliance obligation that you have, but you don't have to spend a crazy amount of money in order to store a lot of data. All right, and then the business value case is also strong. Business value isn't the same as technical value. Business value, the front office only wants to know 3 things. How is this going to contain cost? How is it going to reduce my risk? And not just the risk of downtime, but the risk of being on the front page of the Wall Street Journal, okay, with a clown suit on saying, I just disclosed a whole bunch of data that is private and my customers aren't very happy about that. Or that the equipment investment that I made an investment in is obsolete earlier than we expected. Okay, tape gives you a good insulation against that as well. And then finally, improve productivity. Hey, if I can clear off up to 70% of the capacity of every SSD or every hard drive I've got and store that data on tape because it's hardly ever re-referenced and it's never updated, why are we keeping it on our more expensive spinning rust? Why does that make any sense? All right, now tape, you know, you can go out and do the research on this yourself, but INSIC and Clipper Group and those guys cover tape archive tremendously. And as you can see from the big green spike there, the energy costs alone of storing data in an archive that's comprised of disk is going to be greater than the entire solution cost for a tape-based archive by a mile, by a significant percentage. So anyway, the bottom line is that is driving the interest in tape. And a lot of the cloud service providers who were anti-tape at the outset are now embracing tape with great aplomb. One of the majors had just bought, you know, 100 tape libraries from IBM and bought almost an entire production run from the leading tape manufacturer. So we're seeing tape find its way into Google, Amazon, and especially Azure. All right, and I don't think that that bodes well for the naysayers about tape. So I only had 30 minutes for this. I'm out of time. Those are my hasty conclusions. You can read them for yourself. CA Technologies has a lot of products in its portfolio that facilitate your use of your storage technology to the greatest economic advantage, and I encourage you to go out on the floor and take a look at them. Okay? Thank you. That's what I came here to say.